Okay, now we're going to start talking about the exposure triangle. And you see the triangle here. And it's composed of three parts: aperture, shutter, and ISO. Okay, and we're going to talk about those three parts individually, and then we're going to put them together. And you're going to have assignments that focus just on aperture, just on shutter, and just on ISO. And then you'll have the opportunity to learn what they are individually and then put them together. Most photography classes start here. Every photography class I ever took started here. And I remember sitting in the classroom trying to understand what the instructor was talking about, and I was lost. So that's why I teach 10/20 for composition first, because as a visual learner, I couldn't grasp what this stuff was until I started working out composition. For instance, when I look at a scene that I want to shoot, I start thinking about what do I want to capture. And by knowing that and starting with that experience of forming compositions first, it helps me then understand and select aperture, shutter speed, and ISO to get the photo I want to capture. Okay, so hopefully it'll work that way for you guys too, because I just find this is sort of just nebulous, hard to understand theory without the experience of forming composition and photos to attach it to. Now, every camera has a different layout. Canon bodies will have different layouts based on different cameras. Nikon cameras aren't all the same. We're going to look at Canon and Nikon mostly because those are the two top selling brands. There are others, but most people either own a Canon or Nikon. And so those are the ones we're going to look at. I shoot Nikon. The college has a couple Nikons. And we've ordered Nikons. So when those come in and you guys are able to actually have access to those, it will be Nikon. So we're just going to stick with those two brands for now since they're so well known. Okay, on every camera, however, you will see shutter speed written as a fraction, aperture written as an f-stop, ISO with the ISO next to it. You'll see your shooting mode here somewhere as a large letter. And then your exposure control, which will be a range from -2 to +2. So this is on the digital screen of the camera. So it's going to show you what these settings are. And then you will be able to modify those so that you have control over the final exposure that you capture. Okay, we're going to start with these 5, and you're going to see there are other things down here. Battery, and this is focus. We'll talk about focus, and then some of these other things we'll talk about in other classes. We're just going to start with the basics so that you understand the most fundamental parts of exposure first. And so we're just going to talk about aperture, and this literally is a photo of a camera looking into the lens. And this is the diaphragm that controls the aperture. And this hole is the aperture. And aperture literally means opening. So the opening in which the light comes in and then comes back into the back of the camera and exposes the shot. And these blades that form the diaphragm of the lens open and close to let in varying amounts of light. And that is what we're going to talk about with aperture. All right, so aperture is this one side of our triangle, our Bermuda Triangle of exposure. It controls what is called depth of field, and we're going to talk about that a little bit later on. And it is measured in f-stops. And it's so if you look down here on the first one that says f/1.4, that is how f-stops are noted. You'll have an f over 1.4. This is a fraction. So it's kind of counterintuitive at first. You would think a smaller number means a smaller aperture, but it's the opposite. Because it's a fraction, it's the reverse. So the smaller the number, the larger the opening. Okay, so you're going to see as this number on the bottom gets bigger, the blades get closer and closer, and less light comes in, and the smaller the opening. All right, so aperture affects the amount of light that enters through the lens of the camera into the body to control how much light hits the back of the camera, where we used to use film, but now we have a sensor, and the sensor captures that light and records it. So the aperture size is controlled by these overlapping blades within the lens that form that circle, which is actually more of a octagon or hexagon, to control the light, right? So the wider the aperture, the smaller the number on the bottom, the more light that we're letting into the camera. And the reason you want to be able to control your aperture at all, and you don't on a cell phone, by the way, it's pretty much a fixed lens somewhere in this range, depending on the brand of your camera. It's somewhere between 1.2 and 2.8. It's letting in as much light as possible, because you want to be able to control how much light gets in your camera based on how much light exists in the scene. Also, you want to control depth of field, and we will get there. Okay, so it's easier to think about the aperture apparatus a lot like an eye, because it is. The diaphragm on the camera is similar to the iris on your eye. And just in case anybody's curious, this is just some useless trivia. The resolution of the human eye is 576 megapixels, according to the scientist. iPhone 7 is 12. Okay, so you can see the resolution in your eye is significantly higher than that of the camera. And that is mainly one of the reasons why I lost my train of thought. I apologize. It'll come back to me later. I do that sometimes. I'm going in one place and I get distracted because I was looking at this and I got distracted by this. So here's where we can compare this, right? So here's the lens of your eye. It's the same as the lens on the camera. The aperture is similar to the pupil, which is the hole. The diaphragm and the iris, we sometimes call the lens on the camera, the diaphragm on the camera rather, the iris. The film or the sensor that captures the image is the same as the retina on the back of your eye that acts the same way that captures the image. And just like your eye, cameras see upside down. The image is recorded upside down. Our brains write it backside up. And in this case, your digital screen adjusts it for you. Okay. And then here you can see the iris on your eye, right? And so what happens when the light is brighter, the iris, this is a muscle, the iris narrows the pupil and less light comes in. And when it's darker, the muscle expands the pupil so that you can let more light in. And it works the exact same way, right? So the larger the aperture, same as the pupil, the more light that's coming in. So in a very low light setting, you could possibly take a picture with the f-stop of 1.4 that wouldn't work at f.22. I'm sorry, f22. So the wider lets in more light, just like it does with your eyes, right? So as we talk about aperture is measured in f-stops, and the f stands for focal. And then each stop doubles the amount of light. So from f1.4 to f2, I've now doubled, or I'm sorry, in this case, halved. This way is doubled. So I've doubled or half the amount of light as the previous setting. Now, you may have a whole lot more apertures on your lens available to you than here, and we'll look at those in a chart in a few slides. Aperture controls your depth of field. and that has to do with focus. So when you're using a small number wide aperture, that's when you get the shots where something's in focus and everything in the photo's out. And what's in focus is the thing that you have focused on. As you get a smaller aperture and a larger f-stop number, everything becomes clear. It takes a little bit of practice to get used to this, so that's why we've got an assignment where you're going to do this, okay? And here is actual, we're looking in a lens, and this is what is called wide open for this lens. For this lens, the largest f-stop is 1.4. And you can see as we increase our number, we decrease our opening. Now, when you go to look at lenses, say you're looking at a 50 millimeter lens, you want to buy a fixed 50 millimeter lens to use to shoot, and you see that you can buy some 50 millimeter lenses for $99 and other 50 millimeter lenses are $800. And you're like, what's the difference? F-stop, primarily. For fixed lens, that is, in this case, Nikkor is the glass for Nikon. In this case, this expensive lens is going to give you a larger f-stop than the cheaper lens. So for the cheaper lens, and I have some lenses that were cheap, the smallest aperture you can get, the largest aperture you can get is f-stop of 4.0, and look how small that is compared to this. Okay, so you're paying more when you have a wider focal range, which is what this is when it goes from 1.4 all the way to, they can go up to f64. I think there's some even higher than that. So, and those are really expensive, like tens of thousands of dollars. And it's just because the control over your aperture, the mechanism that controls your aperture, is very expensive. Also, the ability to adjust has to do with the way it's built. And so in this case, you're seeing what happens. This is wide open, and then we're stopping it down. And you can see it literally goes from area, this is half the area, from 1.4 to 2.0. So that's why you're getting half the light, because it's half the size in area of light that's coming in. And you see it just keeps getting smaller and smaller. You can see those blades coming in and reducing this opening. Okay. And so keep in mind that it's obviously not just the aperture. There's no fixed recipe that this aperture will do this. It does work in correlation with your ISO and your shutter speed. So if we've picked, let's just say we've picked an ISO and we've picked a shutter speed, when we adjust our aperture, it's going to brighten or darken our photo depending on which way we go, okay? So the aperture is just one component of our exposure that works in conjunction with the ISO and the shutter speed. So say we've picked our ISO and our shutter speed and we've left it alone. At f1.2 of this man, this is the exposure we'll get, okay? And then if we stop down, and down and down and down and down, the image, the resulting image, as long as the ISO and the shutter speed remain the same, is going to get darker. And so then it's arguable as to which one of these is properly exposed. Sometimes it's just a matter of taste. Sometimes it's a matter of what you're trying to do. That's why photography is an art. This one's probably the correct exposure for this, okay? You could argue this one is. But in this case, it's not the f-stop alone that determines the exposure. It's the f-stop in conjunction with the ISO and the shutter speed. Okay, we're almost at 15 minutes, so I'm going to stop this here, and we will continue in the next video.